ZWS. And today I get to show you what we've been working on for the last 9 months. Here we've got a 4K 120Hz display. This is using our T-Con electronics over here, as well as our DisplayPort interface boards. We're using two DisplayPort 1.2s, but the host system sees one logical display. There we go. One logical display. As we load into a game here, I started an observer mode to just show that a game will run at 4K 120Hz, no problem. We have a little special button over here we can click to have an on-screen display show up, which shows the current frame rate. This will be very useful when this is a real-time graph, it's a flat line because we're not in dynamic refresh mode, but if you were to use a FreeSync video source with this, you would have a real-time graph of your frame rate. Here, as we scroll across the map, we'll see that there's no tearing, which is typical of left and right half monitors. So, aside from plugging two connections into the graphics card, having two connections is transparent to the user. So that's how we have 4K 120Hz. We can do some other things with it. Let's look at the Blur Busters test here. This is the frame skipping test. In this test, one of these boxes is illuminated white while the remaining ones are black, and on the next frame the adjacent box is illuminated. So the white box scans across, and if this display were skipping, or we're dropping frames in the process, you would see a hole appear in this trace. And we don't see that happening here. Hopefully it shows up on camera, but this display is not skipping frames. So this is a real 120Hz in and 120Hz out. We can look at some 4K content. There's a nice video of bees. It's actually a rather nice video. And you see that looks great as well. First-person shooter. Let's open up Counter-Strike. Give that a moment. And what we'll see here is that there is similarly no tearing back and forth. Yeah, left and right, there's no tearing. There we go. Let's load up to an offline match, just with some bots. Here we go. Sometimes when switching modes, the display will turn on and off a few times, even after the fact. We'll be fixing that. So here, similar situation, no tearing. Let's move around a bit. Oops. 4K 120Hz and no tearing. So that works. So if we'll take note here, the name right now is 39-inch 4K120. We're going to change that mode here. Let me describe the situation a little bit. So here's the Decon. It has 4-channel input here and 4-channel input here. Those go to 2 boards, 1 display port each. Suppose that you were using both boards. You'd have 1920 by 2160 at 120 Hz on each half, and they'd be merged over here and sent to the display. Suppose you only have 1 input, or you want to use 1080p only. You're running a game that you don't want 4K 120 at, you might want 1080p, or 720p, or even 540. In those modes, we push a button on our button board here, and we'll change modes. So there are a lot of buttons here. This is the power button, your brightness down, brightness up. This is 4K 120 mode, the dual input. This button here is, you press it for single input 4K, so 4K 60. Then we have 1080, 720, so 1920 by 1080, 1280 by 720, 960 by 540, and then this is the button that shows the on-screen display. So if we push one of those buttons, let's swap over to 1080p. So the display will black out. It'll then tell the computer, hey, I'm a new display, and it'll come back up. And our native resolution is now 1080p. So we see the name of the display has changed. Our resolutions here have changed. Oh look, we're operating at 240 Hz. That's not a lie. This display is actually doing 240 Hz at 1080p. We can still run games. I want to load up that Counter-Strike and see how it looks. We have a test pattern when modes are switching. So that will display. And when we load in, we'll be able to see that, just load into a game, and we'll see that we'll be operating at 1080p 240 Hz. And this is the same panel. Same panel operating at higher speeds, lower resolution. The panel internal driving mechanisms and timings and voltages have been adjusted so that there is essentially no loss of image quality when using these higher speed modes. So here's 1080p 240 Hz. Now, of course, there's going to be no tearing because we're only using 1 input right now. But there you go. Now your 4K display can also match the frame rate of the highest available gaming monitors. Now I mentioned that there's a 720p and a 540p mode. Let's try those. This is going to show up as 720p300Hz. I should run the frame skipping test to show you that we're not skipping frames. Let me do that. Here we go. Frame skipping test. This is just the 720p 300Hz. It's a little hard to see here, but we're not skipping frames. Take a look at the NVIDIA control panel. There we go. 720p 300Hz. The exposed modes are 300 and 240. Some games, older games during my testing, I've found that some games don't like to run over 255 Hz or 256. So the 300 Hz option also has a 240 Hz mode. So now we'll try the fastest mode available, 960 by 540, so fairly low resolution, at 480 Hz. Now, you're just going to have to trust me on this one because the Blurbusters test does not sync at this rate. Maybe I need a faster CPU or something, but it never gets past this syncing waiting for browser scroll to finish it. See, it's sync failure too fast. If there is ever an error that I wanted to get with my display, it's that it's too fast. All right, so how cool is that? 480 hertz. Let me just move the mouse around so you can see. See that. It's probably not going to show up on the phone, but it feels very responsive, and it's really cool to be able to do. You know, this panel can do 4K. It can also do 480 hertz, and that's awesome. So you can use this for pretty much whatever you want. As far as image quality goes, I've got some numbers from post-calibration results. Here we go. So, forgot to mention one thing. This timing controller, right? This is for the 39-inch Innolux panel, the V390DK1-LS1. Now, some of you are probably saying that this is an MVA panel. It's not going to be useful at 480 hertz. Yes, the pixel response time can be certainly exceeding the 2 milliseconds that you have for writing one of these frames, but it's still beneficial to use a higher response or a higher scan mode. Even if you didn't want to run this at such high frame rates, you can scan the image out very quickly and then have a lot of dead time between frames that you could allow the pixels to settle and then use a strobe. If you wanted to do, say, strobing or something. Now, this is pretty cool, but the other thing that's interesting is we can also plug it into the 28-inch. We'll just take a blank PCB here, show you that this T-Con can also plug into the 28-inch. Right now I've only got one working one, so the working one is, of course, back there. Yep. Back there on the 39-inch, we've got our pair of boards over there, a TV off-the-shelf power supply, and I've tested the 28-inch. It performs very similarly to the 39-inch in terms of driving capabilities and such. The 28-inch is a TN panel, so you'll be trading, if you decide to use the 28-inch, you'll be trading some of the image quality for speed. So this is, I think, rated at like 6 or 8 milliseconds response time. Advertised as 6, I believe, for the V390. The 28-inch is advertised as a 1 millisecond panel, so fairly quick overall. Image quality-wise, after tuning and calibration, so post-calibration results, the 39-inch has 82% sRGB coverage, delta E average of 0.3%, delta E max of 1.32%, and contrast level of 2600 to 1. So the blacks on this panel are excellent. The worst aspect of this panel is, of course, the response times being kind of slow because it's MVA, but image quality-wise, it's not so good with reds. It's just a characteristic of the backlight. They designed it that way. I can't change that very easily. For the 28-inch panel, the sRGB coverage is 87%, delta E average is 0.23%, delta E max is 0.99%, and the contrast on the 28-inch does change a little bit when overclocked. When at 120 hertz, the contrast is actually up to, when at 480 hertz, the contrast goes down to about 550 to 1, and at 60 hertz, I think it was rated for 700 to 1, roughly. So it goes down a little bit when overclocked, but we've done a very good job of linearizing that and minimizing that image quality loss when overclocked. So visually it looks pretty close, even at the full modes. Like, we're looking at 480 hertz here, and all the colors are good. There's basically no image quality hit on the 39-inch when you overclock it. On the 28-inch, there's a small image quality hit. The 28-inch is going to be more interesting for users who want to actually use the 480 hertz mode for a game, because it's simply more responsive because it's a TN panel. But that doesn't mean that it's worthless on here. It's very responsive, and it's pretty cool to see, and it doesn't add anything to the price either. One of the other things that we're testing, haven't gotten a Thunderbolt 3 source yet, but this monitor should be drivable through a single USB-C port. StarTech has provided us a little Thunderbolt to dual DP 1.2 adapter, so we'll be testing that for the laptop users. So hopefully that test goes well, fully expect it to, and then you'll be able to use this gorgeous 120Hz 4K display through a single connector on your laptop. Latency. The latency of this whole solution from the DisplayPort to the panel is on the order of a few tens of microseconds. So small fractions of a millisecond, like basically zero. So we've done a really good job there. Anyway, hope you enjoy it. We'll be putting up the pre-order link right here, and you can get your boards. The initial offering for this will be a kit. You will get the T-Con board, 4 LVDS cables. These 3 are the same. This one's different because it has the power. You'll get 1 or 2 of these boards, and you'll get a button board, and we'll probably include some DisplayPort cables too. But yeah. You'll get a kit. What you'll do is plug it into your existing power supply board from your probably like a Seiki 39-inch, and then you'll plug in the T-Con board down there. It's 4 screws. Take off this little cover. All right, unscrew the screws. Take off the cover. Undo the little flat ribbon cable things. Be very gentle with these. Pull them up, remove the cables, put this board in, screw it down. Screw holes are all in the same place. You'll be able to put the cover back on, at least you will on the new ones. The new ones, this is the pre-production board. Of course, it's got some fixes. The new ones will have a dip switch instead of a jumper, and the new ones will have a backlight connection. This is the connection to the backlight and power supply. The new ones will have the FPGA control the backlight directly. In this one, the backlight will be controlled. Well, in the pre-production one, the backlight was controlled with a microcontroller on the input board. But there you have it. That's the full demonstration.